Geometry, what's going on? We're going to tackle section 4 of, is this chapter 10? We're in chapter 10 already? Section 4 of chapter 10, areas of regular polygons and composite figures. It sounds worse than it is, trust me. Let's say that you had a nice pentagon. Can I draw it? That's kind of close. But we're going to pretend that, not like my drawing, that this is a regular pentagon, which remember means all the sides of it equal, all the angles are equal. That looks a little better. And we circumscribe a circle around it. So that circle is touching at every vertex. There's a couple, well, I don't know. There's at least one word that you need to learn what it means, okay? And that is an apothegm. An apothegm is not a nocturnal marsupial native to North America. It is the distance from the center out to touching one of these sides. So from here, like, should I draw this in a different color? Maybe I should. From here out to there, that is the apothegm. And the technique for finding the area of a regular polygon like this is you can divide this up into, sorry, let me do this in a little more organized way. My mind's kind of going all different ways here. Let's talk about the central angle first of all. So the central angle is just from the center, of course, out to every out to consecutive vertices. There's going to be a certain angle there, and that's going to be called the central angle. You can see that if we have a pentagon, there's going to be 5 of these babies. So it's going to be 360 divided by 5, right? If it was a hexagon, it would be 360 divided by 6. In general, if it's what they call any n-gon, so like a 9-sided figure would be 360 divided by 9. It's going to be 360 degrees divided by the number of sides of your figure. That's the central angle. Now, I kind of just did it, but so I'll just leave this. If we want to figure out the area of this figure, we can do what's called decomposing this into triangles. If we draw from the central angle out to each vertex, you're going to get equilateral triangles. And the equilateral triangles are going to have their altitude, which is the apothegm, remember? This side is going to be just the radius of that circle. Same with this side. And this base here is going to be the side of the polygon, right? And you know that the area of a triangle is, area is 1/2 base times height. But in our little triangle here, the base is going to be size. So it's going to be area equals 1/2 the side of the polygon times the height, which is the apothegm. And then furthermore, that's only going to give you one triangle. So we want to multiply it by the number of triangles there are, which is the number of sides of your polygon. So times the number of sides of your polygon. Now I hope that doesn't look too messy, and I hope that makes sense. We're going to do a little rearranging. Instead of writing it as side times the apothegm times the number of sides, Because of the commutative property, I'm just going to switch that around, okay? So don't let that confuse you. Side times number now times the apothem. And do you see that the length of the side times the number of sides? We have another word for that. That's called the perimeter, right? So instead of writing it like this, we could write it like this. So in general, the length of, or the area of any regular polygon is going to be 1/2 times the perimeter times the apothem. And I think that might be it. Oh, no, sorry. Composite figures. Composite figures are going to be easy. This is going to make intuitive sense to you. A composite figure just means that you have a figure composed, that's why the word composite. Let's say that we had a half circle, and then we had a rectangle, a square. Ooh, bad square. But it does remind me of a basketball court, so it makes me happy. So if we want to find the area of this, you can see that all we're going to do is we're going to find the area of this square, and we're going to find the area of the whole circle, cut it in half, and then add this area plus this area, right? Sometimes it's easier to do it by subtraction. If I had, is this a better square? I can never tell till I look at it on camera. I guess it's a rectangle. But if we had something like this and we had a piece taken out like this. Well, in this case, I guess you could do the two triangles and just add them together. Or we could figure out the area of the entire rectangle and subtract this triangle. It kind of depends. I mean, sometimes it's going to be easier to do one, or sometimes it's easier to do the other. If you had a composite figure like this, and we wanted to find this area here, well, then in this case, for sure, we're going to use subtraction, right? You're going to find out the area of the entire rectangle and subtract the area of this inner rectangle, and that leaves you this ring on the outside. Okay, so those are concepts I don't, maybe the apothem is new to you, but the other stuff should be fairly, I think you've used that in algebra. And that's the way you find out areas of composite figures and regular polygons. Okay.